So here's a complete program. So this is, again, a language called C. This is a program that I might write using a simple text editor. How do I actually get to the point of writing this program? How do I get to the point of translating this program into the zeros and ones that the computer actually understands? Well, first, let's tease this apart, just to get some jargon out of the way, even though some of it we'll just keep taking for granted until it more naturally fits into the conversation. So this is a simple program. And in C, just like in Scratch, there's this when green flag clicked block that kind of kickstarts the whole program. In C, as in a lot of languages, Java, C++, and others, main is sort of the equivalent of the when green flag is clicked. If you have a main function, we'll call it. Scratch called them scripts. We'll call them functions. But they're essentially the same for today's purposes. So long as your program, the text file you're typing in on your computer, Mac PC or whatever, contains the keyword main, it's probably an executable program, something you can run, something you can double click on. Now, you can't just type main. You have to adhere to some annoying conventions. And among those conventions in C are, first, you have to say that main return something. And we'll come back to this. But for now, just take for granted that main must be prefixed with the keyword int, int. Now, as an aside, what is this all about? Well, if you've ever used your own Mac or PC or Linux box and something weird or bad has happened, you get some error message. It freezes. Odds are you've seen a little text box on the screen that says something like an error has occurred, you must reboot, or your changes were lost. And then it'll often say something like error -1 or error 253 or some random number that's of no value to any of us. It's probably of some value to the programmer who wrote that program, because programs, or specifically functions, can return numeric values which are not often useful to people like us, but they're useful to the programmers or other parts of the program. And generally, 0 means everything went perfectly. 0 is, it's a little counterintuitive in that 0 we typically say is false or no, but 0 is perfect. And why is it perfect? Well, if so long as you choose 0 to mean success, this program worked great, it quit without any problems, you have a seemingly endless supply of error codes that your program can return if something's indeed broken. So when you see these error messages on the screen and you see some numeric value, they're almost never the number 0, it's the number 1 or 2 or -1 or -3. And that's so that Microsoft and Apple and others have, again, so many possibilities for error codes to return. Now, it's not always error codes. We'll see other uses. But for now, the reason that main returns a number, because it's some way for an individual program to tell the OS it worked great or there was a problem. So what else is there? Void, I'm going to wave my hand at for now. But know that programs can take input when you run them by typing a command or by double clicking them. Void just means, this program takes no input. It's so simple. It just does something, doesn't take any input from a human. The curly braces are what keep everything together, just like the yellow structure of most Scratch blocks. Printf is what we're going to call a function. So main is a function, printf is a function. And what's nice here is that printf, a function can call another function. Now, what's a function? You can kind of infer it from the name. It's like a miniature program that just does something. It has some functionality. So printf's purpose in life turns out to print something to the screen. Main's function in life is to kickstart a program the moment it starts running. Main is what it's supposed to do first. Now, functions here, printf has this parenthesis and then another parenthesis inside of which is a quote unquote. And just to see if we can tie the conversation together, what would you call perhaps the thing inside quotes here? Yeah, so it's a string. So we've used the word string before to just generally say a word, a phrase. So indeed, printf can take as input a string, and that string is what's printed on the screen. And that's it. All this conversation just to say, here's how you implement hello, oh hi world on a computer, but it gets us to the point now of being able to write and run this. So we need the ability now to write and run a program. So how do we do this? Well, those of you who are coming at this with prior programming experience, you probably use something like Eclipse or NetBeans or Emacs, or there's a seemingly infinite number of programs with which you can write software, write programs. But again, I could do this on my Mac. I could open up a stupid little program called TextEdit. It's analogous on a PC to notepad.exe. And I could just start typing include standard IO, int main void printf. I'm literally just transcribing what we saw before. Oh, hi. I think I did that yesterday too. Oh, hi world. And again, there's some syntax in here I'm waving my hand at, the \n, the semicolon, but we'll come back to that. All I need to write software is a text editor like this. You could even use Microsoft Word so long as you don't save it as a .doc, but you save it as like a .txt file or something like that. But that's not the right program to use. Really, you want a program dedicated to programming, as we'll soon introduce. So unfortunately, this is not quite zeros and ones, right? I could, if I really wanted to create a nightmare for myself, write Oh Hi World by expressing myself with zeros and ones, saving that file with a special program, and then double-clicking its icon or running some command. But this is obviously not human-friendly, nor is it human-friendly to feed punch cards or tape into a machine. Instead, we write programs in higher-level languages like C that look like this. But what do you need, especially if you have some prior background, what do you need to do with this source code in order to convert it into those zeros and ones? Yeah. So there's this other utility that's out there, and it's called a compiler. And it's not a text editor. It doesn't let you write programs, but it lets you prepare programs for running. So step one in writing a program is just write the program in your choice of language. For now, we'll use C. Later in the semester, we'll use PHP and JavaScript. But we just need to type it at our keyboard in some simple program. But step two, usually, at least with a language called C, we have to convert this into zeros and ones by passing this file as input to another program that will essentially convert this to zeros and ones. And then once I have those zeros and ones, then I have a .exe on my desktop, to borrow Windows speak. Or I have a .app on my desktop, to borrow Mac OS's speak, whereby I can now run this program. So how do we do this? Well, if you have a Mac, you can go to the Mac store these days. You can download a program called Xcode for free if you have Lion, or you can pay some money if you have an older version. And you can then install a compiler and, again, a program called Xcode. And you can do all of this. Windows, there is no Xcode. That's an Apple product. So instead, on Windows, you go and buy Visual Studio from Microsoft, or NetBeans, or Eclipse, or some other tool, though there are freely available alternatives. But that, too, is kind of a pain in that it doesn't come with the operating system. And in a class of this size, we'd have all sorts of people using all sorts of versions of Mac OS and Windows and even Linux and other OSs. And my God, it would be a nightmare, all using different computers trying to get all of our code to work on completely different hardware. And so thus was born the CS50 appliance. And we made a mention of this last week, but the CS50 appliance is our way of saying, use your Mac, use your PC, use your Fedora machine, your Ubuntu machine, and instead install inside of a window on your computer our operating system. Now, the CS50 appliance is going to be an operating system that runs inside of a window on your own computer. That operating system happens to be called Linux, with which you're probably at least familiar with by name. It's freely available, very popular, super popular in the world of websites and running servers, primarily because it's free and high performing. We're using a specific flavor of Linux called Fedora. There's all sorts of competing alternatives, Fedora and Ubuntu and all of these big names. We chose Fedora, but it doesn't really matter which one you use. But once you install this thing, we will all have, no matter what OS you brought to campus or what computer you brought to campus, a similar environment that looks a little something like this. And it actually looks like Mac OS or Windows. All of these manufacturers kind of put the menus in different places, and the icons might be called something trash or recycle bin. But at the end of the day, they're all stealing ideas from each other. And at the end, it all kind of looks the same. So if you look at top left here, you have a home directory. This is going to be like My Computer or Macintosh HD. You have File System, which is everything. You have the trash can. At the bottom left corner, you'll see that we don't have a Start menu. We have a CS50 menu. And inside of that is going to be links to programs. And so long story short, even if you're using Mac OS or Windows, starting this week and beyond, we're all going to be running the same OS inside of a window on our own computer. So how do you do this? Well, we'll provide you with instructions with the first problem set. But know for now that you'll download a free program, happens to be called VirtualBox. This is a program that exists for Windows, for Mac OS, for Linux, for Solaris. If unfamiliar with some of those, they're just other operating systems. And when you run it on your computer, it looks a little something like this. On the left-hand side, you see a list of all of the virtual machines that you have installed on your computer. And you see on the right the virtual specifications of those computers, of those virtual machines. So what is a virtual machine? It is just a computer running inside of a window being tricked into thinking that it's actually running on a physical hardware CPU with physical RAM and a physical hard drive. But no, I mean, we've gotten so sophisticated as a society that we can actually trick Windows and trick Linux and even, with some effort, trick Mac OS to thinking that those operating systems are not running on, that those operating systems are running on a piece of hardware, a computer that you bought at the store or online. But in reality, you're actually running it inside of a window on a computer that you bought online or in some store. And you can really mess with your mind if you think about running a virtual machine in a virtual machine in a virtual machine, but that tends not to work so well. So you kind of do it once and you leave it at that. But what's the advantage here? Well, just as an aside, and this is really just a teaser for things to come, these days, most of your laptops, if relatively new, have probably one CPU, but multiple cores. You might have 2 cores typically. Well, these days for servers, you might have 16 cores, 32 cores. And that's essentially equivalent to having 2 or 32 or more brains inside of your computer, all of which can do something literally simultaneously. Now, the world is not very good at taking advantage of 32 CPUs, even 2 CPUs. We humans, we don't check our email all that quickly, despite what you might think. You don't need 2 gigahertz of power times 2 to check your mail. So even our computers have a lot of spare resources, at least if they're 3, 4 years old or newer. And so what virtual machines take advantage of is all of the spare brain power and memory and disk space that we just don't typically use. You don't use all of your computer's resources for Microsoft Word, for instant messaging, for Facebook, and the like. So the virtual machine is going to borrow some of your CPU cycles, so to speak, some of your RAM, some of your disk space. So what you see here in the CS50 appliance, you will download essentially a zip file, a compressed file from the course's website for the NXP set. When you follow the instructions, you'll see that the virtual machine you're installing has, turns out, 768 megabytes of RAM. Now, by modern standards, that's actually not all that much. And we could crank it down even further, because most of your laptops have at least a gig or 2 or 4 or 8 these days. So realize these are all configurable. But once you then double click CS50 appliance at top left, voila, your Mac becomes Linux or your PC becomes Linux. And if you maximize the screen, you don't even realize what operating system you're actually running. And so now we're all on the same page. Now, as an aside, I've also had this icon here. I just for fun installed Windows in advance on my Mac inside of a window, so that also in class moving forward, if we ever want to have a conversation about what something looks like on a Mac or a PC, I don't need to have 2 separate computers. I can use just the Mac by default, but then open a Windows window, and we can see what it would look like for the half of you or so that run Windows 7 or XP or Vista. So realize that's another advantage as well, to run multiple operating systems at once. So enough about what the technology is. Let's actually use it and do something interesting. So once I double click this icon, a few seconds or minutes later, the operating system would boot up in a window. If I maximize it here, I now have my home directory, like my computer, and I have the trash, I have this menu at bottom left, and I have all sorts of programs which we'll explore over time. But the one that I care about first happens to be under programming. And you'll see there's a few things under programming. One is called gedit. There's a few other things. We actually installed Scratch in the appliance, even though you didn't need the appliance for the first PSET. We just put it there so that, in theory, you could take the whole course inside of this appliance. We'll see a program called Eclipse later in the semester, which is an even fancier tool with which to write programs. And we'll see Terminal as well. But for now, I just want gedit. gedit is going to be a slightly better version of TextEdit on a Mac and Notepad on a PC. And it's still pretty simple. I mean, it's mostly a white screen with very few menus. But it's in this area here in the middle that I'm actually going to start writing my programs. And it's at the bottom of my screen here where it says jharvard at appliance. And there's this blinking prompt. That's where I'm going to run my programs. So typically in a Linux environment, you don't have to double